So let's look at how acids and bases are going to react with each other. So we've defined the Bronsted-Lowry, and we said that the acid is going to donate a proton and the base is going to accept a proton. And so when we have the acid has a pair of electrons that are shared between the hydrogen and the anion. And so the electron pair, when this breaks, is going to stay with the anion. And so, because it's liberating this H+, which doesn't have any more electrons with it. The base, which needs to have an electron pair with it, is going to then accept that hydrogen that's been donated, and which will typically give it a plus charge, and so it has gained that hydrogen, so that is obviously the base. Now what happens is that since the anion has retained those electrons, it now has one more electron than it does protons in the case of a monoprotic acid, and so it will have the negative charge. So the product that you form is called a conjugate base or a conjugate acid. So if you have an acid that loses a hydrogen, then its product is its conjugate base. And the only difference between a conjugate base and the acid is the loss of this hydrogen. So if you need to know what the conjugate base is of an acid, you just remove the hydrogen and account for the change in charge. With a base, you're going to have a conjugate acid because you have added the hydrogen to that, making that HB. Notice that we have arrows going back and forth because you can then lose this again and go back to this being a base and this being an acid. So it's a reversible reaction. And so when this happens, we call these conjugate acid-base pairs. So your HBr and your Br minus are conjugate pairs with HBr as your acid because it has an H in the front, and your conjugate base is your bromide. Water can act as an acid or a base, remember. In this case, it's accepting a hydrogen or proton, and so it becomes a conjugate acid. The net charge has got to be the same on both sides. So since you had a zero charge on this side, you have a -1 and a +1. So you have a zero charge on the other side, even though you have ions. So remember that when a species gains a proton, it's going to gain a +1 charge. And when it loses a proton, it's going to gain a -1 charge or become a -1. Some compounds have a hydrogen atom and a lone pair, and so it can function as either an acid or a base. And our classic example of that is water. Water, if you can add a hydrogen to water and form your hydronium ion. You can remove a hydrogen, from water and produce a hydroxide. So this is called ampho, as in like an amphibian can go on land in water. Amphoteric can be either an acid or a base because it has a hydrogen atom and a lone pair of electrons.